9.3, arc length, surface area of a solid, revolution, find length of a plane curve, find surface area of a solid revolution attained by parametric equations. Let me find my spot in my notes. All right, 9.2 was tangent lines. 9.3 is the arc lengths. All right. Arc length formula. Are you guys okay with this? So it's the slope of the dx dt squared plus dy dt squared. It's the square root of that. So it's basically Pythagorean theorem. Basic. Where if I have a squared plus b squared equals c squared, I could say that c is equal to the square root of a squared plus b squared. So it's basically coming out looking like that. So if you think about it in those terms, that we're getting this from where we're getting on the Pythagorean theorem to figure out this. The length is going to be from a to b, the integration of those. Arc length is always with an S. Are we okay? All right, so find the length of S curve represented by these two parametric equations. So let's go through and let's find my things I need to find. Insert page after. So I get x of t. So x of t is t cubed plus 2. And y of t is 2t to the 9 halves. 2t 9, 9, come on, 9 halves. All right, let's find my dt. dx dt is going to be, what is it? 3t squared. Dy dt is 9t to the, I'm taking away 2 over 2, right? So it's 7 over 2. Okay. All right. From where t equals 1, the point where t equals 3. Yeah. So I'm doing s equals integration from 1 to 3 of the square root of my 3t squared plus 9t 7 over 2 squared. And that is dt. That's pretty straightforward, right? So before I could do the square root or any of that other stuff, let's do the math on the inside. We've got to do the math. We've got to do all that math on the inside to be able to, go and take and be like, all right, let's figure out what the blah, blah, blah is going to be. So do all the math first. So I'm still going to have integration from 1 to 3 square root of, that's going to be 9t to the t4, right? And this is going to give me 81t to the Oh, I'm telling you, I just got no energy left. I'm talking too much. I'm out of words. No words left. I know, right? All right. Okay. Anything I could do with this?
Can't you use that?
I can. But nothing clearly is jumping out at me and saying, you sub me, right? So it's all inside a radical, isn't it? Is there a perfect that is amongst that I could take out?
19 to the power 4.
Very
And
good. So I'm going to take out
9
9t to the 4th, right? And I'm left with 1 plus 9t to the 3rd Yes? All right, so since I was able to factor that, I'm going to move to a new page. I'm running out of it here. Insert page. So because I still have that 1 to 3, it was plus 9t3. Yes? Okay, good. So I'm gonna take care of this. This is gonna give me 3t squared. And now I'm gonna use sub my 9t, my 1 plus 9t cubed. 1 plus 9t cubed. Because I was able to take that out, I've now been able to look at it and say, hey, look, this is going to take care of itself here in a minute. So because when I do this, I'm going to have du is equal to 27t squared dt. And I'm going to do something kind of weird here. I'm gonna divide both sides, not by 27. I'm going to do by 9. Okay, so this is going to be 1 over 9 du is equal to 3t squared dt. Now, by doing what I did, all this right here is going to be my u now, right? So that's going to give me my u to the 1/2. But because I did this the way I did over here, I have my 3t squared, which is going to go away with my dt because I have this and this together. I'm going to substitute that with my 1/9 du. So my integration from 1 to 3, 9. I said 9. Come on now. 1/9 du. So this whole big mess just turn into something that just like falls together. It you know, comes out pretty, just pretty. Now can we do my integration? Say yes. Okay, let's do this integration now. So this is going to give me 1/9 of u to the 3/2 2/3, and that's going to be from 1 to 3. All right, that's going to be ugly. I don't like that. Okay, so that's going to be I don't know. It comes out something like this: 1/9 bracket 6 rad 3/3 minus 2/3.
Wait, did you plug in 1 plus 9t?
Huh?
Did you plug in 1 plus 9t cubed into which one of the steps?
Good points. See, like I said, I'm kind of slow this morning. Do I want to do all that? No, I don't. All right. I don't want to put it back in. That's ugly. I don't want to put it back in.
Just change the bounds?
I know. Let's change our bounds. Okay, so if we say that the bounds are supposed to be 1 and 3, change the bounds. So 1, if I plug in 1 here, that's going to be 9 plus 1 is 10. And my upper bound, 3, would be 3/3 is going to be 27 times 9, which is
243
243.
plus
244. Wow, that's even uglier.
1.
Wow.
This is one big number.
Okay, I lied. I don't want that.
At least you can use the calculator.
Okay, so what do we say? Said 1 and 3. Oh yeah, 1 and 3 is a lot better than. Okay. All right. 1/9 bracket 2 1 plus 9t cubed to the 3/2. Yes. There we go. All right. All right. Let's see what we get there. It's still ugly. I know you guys are doing this calculating for me, right?
Yeah. I have a decimal.
Do you know why you have a decimal? Because you're still going to have rad 3 in there somewhere.
but with decimals.
Okay.
What is that number? 14 million?
Is it this one in blue or is it this one in?
The one in blue.
Yeah, so this is 25, basically 2520. Did you do by the 1/9 also?
What do you mean? Oh yeah, divide by 9.
Oh, divide. Okay. See. What is it?
279.9.
Like that? Okay. Not too bad, right? So your calculator is your front, please. Alright, let's see if I could actually get this to work today. Settings. Polar. Alright, so what was my function? No, this is parametric, not polar. So what did I start off with? T cubed, right? T cubed plus 2. Y equals. Okay. 2t 9 over 2, and it was from 1 to, you said 3? Menu, analyze. No, this one doesn't do it. There you go. So this is what our graph is going to look like from here to here. Parametric, what our graph is, and we're looking for the arc length. It's not liking me today. So that's basically still not doing it because it's still going too far, showing too much. Anyway, but still, So that's how you actually put in these parametric equations. You make sure you go to your menu, entry, parametric. There's some polar also, but yeah. Anyway, parametric, and then from there, just enter in your functions, and then I know there is a way. I can't remember if it's on this or the CS that will do it. Anyway, all right. You guys want to go over this next one, or just keep working on stuff? Working on homework? Okay. All right.